let's take a look at this. So, if we look at our table, this one's a little bit easier. There's no negative area. Well, there's negative area for area under the curve, but we didn't have to switch the A and the B at all. But definite integral from 0 to 0, that's an easy one. Remember, whenever A and B are the same, it's going to be 0. F of 3, we're doing a definite integral from 0 to 3. So the area under the curve from 0 to 3, that's represented by the blue here. It's under the curve, so that means the height is negative. We have 1/2 times base is 3 times height is -6, which gives us an area of -9. Then, kind of like the last one, I went from 0 to 5. I already know what it is from 0 to 3. I just need to figure out what's it from 3 to 5, and I can add those up. So this triangle right here has a base of 2, height of -6. So 1/2 times 2 times -6 gives us an area of -6. Add those up, we get -15. Other way we could have done it, base of the big triangle right here is 5, height is -6. So 5 times -6 divided by 2 gives us the same answer. Here, from 5 to 7, that triangle has an area of 6. So if I add all three of these up, that gives us the definite integral from 0 to 7. So the 6's cancel out, we end up with -9 again. And then for this one, this last rectangle here is just 6 times 3, 18. So to get the definite integral from 0 to 10, we're adding up all those areas. Or we could just take what we had last and adding up that 18 on top of that. So we end up with 9. Questions on that part? All right, then where is on what interval is f increasing? Well, we talked about that in the last one. It's increasing when the derivative is positive. So again, the derivative of capital F of x is little f of x, which is this graph, right? So this is the derivative of f of x. And that derivative is positive, the y value is positive from 5 to 10. And then it's negative from 0 to 5, so that's where it's decreasing. Change those colors so it kind of matches what we wrote with. So this is the increasing part, and this is the decreasing part. Questions on that?